What we got? 19, highest number?
Yeah.
Perfect. Read it for me. Here we go. Let's start right off. If you need to look back at your notes from yesterday, look back. I'm not looking for an answer or a fraction or anything. Read it for me. What did I just write in some notation here? 2, start us off. What's that say? Probability. Okay, got your notes from yesterday. We look back and we see it, we're going to know it better. Probability of?
I know. A. Getting A.
Okay, we're working one at a time here. First letter, probability. Jenna, probability. What's the first letter here? So event A, probability of A, and I'm not letting you off the hook for this one, what that vertical bar means. Given. Probability of A, given, that's what the vertical bar means. B has happened. All right, remember, B has already happened, so that's what it's going to be out of. Next one, read it for me. And I know this seems pretty elementary-ish, but I don't care. 8, what do you got?
Probability of A or B.
I'll wrap it around that kid's neck. A or B. Okay, of course that was easy to read, but what I want you to remember is you better watch out for the or questions. When it could be A or B, because whatever they have in common, we need to subtract. Okay? Please remember that. Anytime you're asked for an or question, we need to subtract out what's in common. Because remember, yesterday we counted numbers twice, we counted people twice. So subtract out what is in common. All right, so that's what I just wanted to review real quickly, because as you guys know, today's day 2 of 3, and we're done. Okay, day 2 of 3. Let me go to the assignment from yesterday. Anything we want to go over there, because I'm fighting a battle on 3 ends right now. Battle number 1 for me is getting you to class. Battle number 2 is, if you're not in class, are you actually making it up? And the third battle, which is probably the toughest, is actually practicing that when I'm not here. Anything we want to go over? Any question at all? Ryan, let's roll. 11, everybody. Okay, this is Bert using a table. All right, finding probabilities using the table. A, and even though Ryan asked, I'm still calling on people, so be ready. Number 11 from yesterday's homework. What's the probability you select a person who chose chocolate ice cream? Look at your chart. How many like chocolate or chose chocolate ice cream according to the chart? 11. How many chose chocolate ice cream? 90. We talked yesterday. Probability, always a fraction, not bigger than 1. Out of 200. 90 out of 200. Pretty basic. Reduce if you need to. All right, what's the probability that a person who chose chocolate ice cream also chose peanuts? What do we know already? They chose chocolate. They chose chocolate already. So everyone, is it going to be out of 200? No. How many chose chocolate? All right, so now it's out of 90. See the difference? I already know they chose chocolate. So now this is the only, where is it? This is the only row I'm looking at right now. The ones who chose chocolate, how many chose peanuts? 50. Okay, 50. And then reduce if you want to 5/9. Good so far? All right, what's probably a person who chose sprinkles? Stop. Is it out of 200? No, it's only out of the sprinkles, which is
130.
130. Good call. So out of those 130 now, how many choose strawberry? There you go, guys. Questions? Or anything else you want to ask, or anything that's bothering you about this? Elliot.
Just on that one, you said it doesn't matter if we reduce it or not.
For me personally, no. I just warn students that if you're doing a multiple choice question, chances are very high that all the answers are going to be reduced.
Okay.
If you leave this like this on Thursday's test, I don't care.
Okay.
Still correct. Yes, Libby. 5. Okay, another one using a table. So if one of the 40 selected, what's the probability they like iOS and Android? So they have to like both. It's not one or the other. They have to like both. So out of the 40 people I've surveyed, I'm looking at the chart, like iOS, but at the same time, they have to like Android. It's not a one or the other situation. And there's only one spot where that happens. Likes iOS and likes Android. There's only 7 of them that like both of them. Okay, only 7 that like both of them. Other questions? Anything else? Hi, Maddie, what's up?
Can you do 7?
Okay, what's the problem? Okay, great. Now I go from and to or. Or. They like iOS or Android. All right, well, let's first start with they like iOS. How many of them like iOS? According to this table, how many like iOS? 27 like iOS. How many of them like Android? 19. But I warned you, something happened. I counted people twice. I counted them because they liked iOS, and I counted them because they liked Android. And how many people did I count twice? So I need to subtract out those 7 people I counted twice. Still over 40. You see why I got to subtract out the 7?
Yeah.
Okay, because I counted them twice.
Where did you, I get why you subtracted out the 7, but how did you read the table where the 7 was? I'm just like,
Okay, ready? So let me start. Likes iOS, ready? That's all those guys. 7 and 20 of them. Likes Android. That's all those guys. Notice I counted 7, those people in 7 twice. I counted them because they liked iOS, and I counted them because they liked Android. So that's why I subtract out 7. All good? Anybody else? We're all set? Okay, here's what I'm going to show you today. I don't have a table. I don't have a Venn diagram. And I can't do this anymore. You know, H1, T1, T2, H2, like we did yesterday. But I'm still going to ask and, or, and given questions. So how do I do this if I'm not given a table, a Venn diagram, or I can't list them out? Go to the front of your, very front of your packet, please. Very front of your packet for me. All it says is probability at the top. Then it has huge, nice blank space for a reason. Because if there's no Venn diagram, if there's no table, and I can't list out my possibilities, we're going to have to rely on some formulas today to find all these. Okay, so let's just get a formulas. And you're going to, unfortunately, yes, you're going to have to flip back and forth from your notes to the front page. Okay, so just get it prepared right now, because we're going to put 3 formulas down before the end of class. All right, let's go back to your notes. Okay, let's go back to the notes. Good questions on the assignment. Keep them coming. Formulas. There you go. I had it already planned. Here. Before we start, before we start formulas, I do have to mention flipping a coin. I'm going to flip a coin, and I'm going to roll a die. 2 events. And we're going to start talking about if 2 events are independent of each other or they depend on each other. Here's what I mean. I flip the coin. Boom, whatever comes up. Does my flip have any effect what I roll on this die?
No.
Yes or no?
No.
No, correct, right? They don't. So I say flipping a coin and rolling a die are independent because one has no effect on the outcome of the other. We're all right there. So on number 1, rolling a die, and now it's spinning a spinner. Does one have any effect on the outcome of the other? No. So we're going to say these 2 events are called independent events. One does not have any effect on the outcome of the second. All good. Pick 2 flashcards from a stack of 30. I'm sorry I didn't come prepared with cards, but So you got a deck of 30. I pick a flashcard out, put it down. Will that affect the second pick I have?
Yeah.
Why are you guys saying yes?
Well,
Well, how many outcomes did I have at the beginning of my deck? 30. Took one of those bad boys out, put them down.
Now you have 29.
Now I have 29.
So it's dependent.
So it is. They do depend on each other. Correct. If I don't replace it. All right. You got coins in your pocket. You take one, notice it, put it back in. Will it affect the second time you pick? Do you still have the same number of outcomes?
Yeah.
Yes. Why? Because you put it back in your pocket. If I kept it back out, they would be dependent on each other. Everyone see that? If it affects the number of outcomes, it's dependent. If it does not, it's independent. If your number of outcomes remains the same, it's still independent. All right, so I just wanted to go over that because those words will be coming up. Oh, new symbol time. New symbol. You guys already know this is what? Given, right? You already know that. Ready for our new symbol. And. Our new symbol for and. We did a lot of those probabilities yesterday, right? I like iOS and Android. Ready? Little upside down U. Little upside down U. So when we start writing symbolically, you're going to see that symbol, and that's going to mean and. So both of them have to happen. And I told you already, we're going to have to answer some of these and questions without a table or a Venn diagram. So how am I going to figure it out? Formula time. Formula time. Go to the front of your packet for me. Let's write down formula number 1. How do I find the probability of and with two events that I have no table or Venn diagram for? Ready? P for probability. Here you go. Here's the new symbol. A. Everyone good? New symbol. A and B. Can't get that dot out of there. Here's how you find it. Very, very not complex at all formula. You take the probability of the first event, A, and you multiply it with the probability of the second event, B. That's it. That's how you find A and B now. A and B. All right, let's use it. Let's use it. Let's use it. And you guys see right there, sometimes A and B can be written as with the symbol. I'm going to keep using the symbol. I love that symbol. All right, so the first problem here is a problem from yesterday. What's the probability a coin lands on heads and a 6-sided die shows a 2? So yesterday, don't write this down. If we were doing this yesterday, and probably right now, you guys would be like, oh, all right, I'm going to flip a coin. I could go H1, H2, H3, H4, H5, H6, right? And then we did it for the tails. We remember writing this out? Yeah, we did. Yep. All right, so writing it out, what is the probability it lands on a tails, or heads, excuse me, and it's going to show a 2. Don't say anything. Think about it, and I'll call on somebody. So here are all my choices. Heads and a 2. Not or, and a 2. Heads and a 2. How many of them out of how many? 17? How many choices do I have? How many choices do I have?
12.
Out of those 12, how many are a head and a 2?
1.
Okay, yeah, that's my answer. 1 out of 12. Let me show you how to use the formula now to get 1 out of 12. Ready? Probability. Here's where you can get creative. However you want to express heads, you express heads that way. I'm going to do an H. If you want to write out the actual word heads, draw a coin with heads on, I don't care how you do it. I don't. And, there's our symbol, heads and a 2. You want to write the word 2 out, you want to put piece up, I don't care. However you want to denote that. Now go to our formula. How do we find an and probability using the formula? Whoa. Don't give me numbers. Just tell me probability of this, and tell me what operation we're going to do. Look at your formula sheet. 14, it's going to be probability of. Okay, in this case, I have an H, right? So I want you to use that for me. Probability I get heads times, which is this case getting a 2. Good. So that's what I would do to find this. All right, ready? You flip a coin. What's the probability you get a head? Hey, I'm not even looking at this anymore. I don't want to write it out. Done. What's the probability you get heads? 1/2, right? Heads or tails? Times. You got a die. What's the probability you roll a 2? 1 out of. What's going to happen? Numerator times numerator. Denominator times denominator. There's 112. Okay?
Can you explain the 1/2 times 1/6?
Okay, when you multiply two fractions, there's no cross multiplying. That's for if they're equal to each other.
No, I just mean like the how you got the half.
How I got a half?
Yeah.
Getting a head on a coin. One coin, flipping a head.
Oh, okay. So
It's either heads or tails, right?
okay.
So 1/2. Rolling a 2 on a 6-sided die. There's only 1 2 out of 6 options. Okay, good? Everyone else all right? All right, now let's go here. Here's what I'm talking about. No diagrams, no tables, and you can't list out all your options. But I'm still asking for an and probability. Okay, it's going to rain, 0.6. Don't get freaked out. Probability can be a decimal. That's just what? 60%. That's all that is, 0.6. And then I got another event that the Knicks will win in Los Angeles on Friday is 0.3. Great story. What's the probability it both rains in Boston on Friday? Whoop! And the Knicks win the game they play. You are not listed out anything. You got to use the formula. All right, I know it's and. So probability of, you guys use your own shorthand here, abbreviations. It rains, I'll just call it R. If you want to put B for Boston, go ahead. And here's my new symbol. Knicks win the game on Friday, however you want. K, W for win, doesn't matter. That's what I'm looking for. Okay, you guys have a formula on how to find this. What's the formula say it should be equal to? Talk to me. Here we go. 12.
Probability of
Use my letters, please. R.
times probability of.
Thank you. There you go. That's it. That's how I'm going to find it. And hopefully, those values will be stashed in the problem, which they are. Okay, rain. 0.6. Win. There it is. That's all there is to this for this one. And we got 0.18. Just so you get some context here, that means 18% too, remember. That's 18%. Usually we don't see much probability with decimals, but that's 18% chance that both happen. Molly, come on.
For problems like this, why don't we put it, like, why wouldn't, for example, for like the winning the game, would we put it like over 2 because there's 2 options, win or lose? Like, why do we?
Say that again.
Like for the game, like they can either win or lose. Like, why don't we put it?
Oh, no. They're telling me the chances that they're going to win is 0.3.
So like there's a
Because it's not always 50-50.
Okay.
All right?
Yeah.
Yep. Sarah.
could you have written 6 out of 10? or
Fine.
5 out of 10?
Yeah, I'm fine with that. That's fine. Because Sarah and everybody else, probability, decimal, percent, fraction. All 3 are acceptable for probability. So you want to go 18%, I'll accept it. 0.18 or 18 out of 100, I'll accept it. Okay? Other questions? Back to your formula sheet, please. Yesterday we did and probabilities, and we also had or. So we're going to need a formula for that. Yeah. Probability. Let me introduce you to the or symbol. Flip it. You got the or symbol. Or. Little bit more involved than the and formula. Here it is. Probability of A. Ready for the change? Plus probability of B. And if anybody remembers what we always had to do yesterday, for any or one, we had to subtract what was in common. AKA, what do I mean by what's in common? The probability of A. No, A and B, right? Together? Well, how am I going to find that? Look at number one. You got a formula for this?
Yeah.
Okay. So even if the problem doesn't give it to you and all you have is A and B, you can find A and B. Okay? So that's how we're going to find R. A plus B minus the and. Let's go! Next up. My same exact Rain and Knicks winning question, except I substituted in the word or instead of and. So Rain's in Boston or Knicks win on Friday. So here we go. Probability of Rain or new symbol win, or whatever you wrote for your letters. Okay, how am I going to find this using your new formula now in my letters? All right, your or formula. How's this going to be calculated? 3, how's this going to be calculated? Probability.
Of green.
Yep, R.
And then plus.
Plus, good, because it's or. Plus probability of.
Winning.
Yep.
Minus, and then we have to minus 0.18 probability.
Pretend I don't know what the previous answer was.
Probability of R. What is it? Now I'm all confused. Probability of R times probably. Wait, do I not do that?
No. I'm just going to write R and W.
Oh.
And yes, that's how you find it is.
Are there two, so like there are two options you could also do?
But I also could I.
Because you see like the two equations.
It's the same thing.
Oh.
Yeah. They're just substituting in the and for the previous formula we had, which is A times B. All right, let's do this. Who's up next? Let's go 8. What's the probability of rain?
Probability of rain is
0.6. Plus, how about winning?
0.3.
0.3. Now, hey, I know this is tough. We just did the problem, so you know the answer is 0.18. But let's say I never did question 1. How can you still find the probability of the R and W? Minus, let's say I don't know the answer is 0.8 from last problem. What's the formula say for the and? Rain times wind, right? If I didn't know the answer was 0.18 already. That's how I would find the and. Hey, are we seeing how these formulas are related now?
Mm-hmm.
How I need formula 1 to plug in here if I don't know the answer already. All right, go ahead. Now we're just calculating. I forgot what this was. Where's mine? We got 0.72. So a little bit better chance than both of them happening, right? 18% versus 72. Questions? The Bro Club all right back there? Okay. Just checking. All right, how about we take some French and stats here for number 2. 42 of you take French, 26 take stats, and 8 take both. What's the probability you take French or stats? Or. Everyone seeing no table, no Venn? Got to use the formula. You're forced to. Got to use the formula. Probability of French, I'm going to call it F, or my new symbol, that's and, my new symbol, stats. No numbers, just how you're going to find it. Tell me probability of this. Keep going. No numbers yet, though. No numbers. 18, how are we going to find this? This will be the probability of F, yep, French. S, finish strong, Nora.
probability of French times probability.
Okay, you want to do? Yep, that's fine. I'm going to just put the and there. But yes, that's how you do it. French times Spanish. Got it. Or statistics. Right, ready? Who's up next? Got probability of French for me? 6. Probability of French.
42.
Now, I just got a quick comment here. This is okay if you want to do it this way. But remember, you can't have a number bigger than 1 at the end, right? So if you want to do it now or at the end, it's got to be out of how many people? 100. So whether you add up the kids now and make it out of 100 or do it out of 100 right now, I don't care. Just it's got to be out of 100 at the end. Plus 42 out of. Oops, the 42. Yep, relax. There you go. 26 out of 100 minus. How many take both? 8 out of 100. All good? We sure?
Wait, why is French and statistics, why is that 8?
8 are taking both.
Oh,
Right? 8 are taking both. All right, let's just get to you guys can. By the way, in all seriousness, because this does make me sad, do we know how to use the fraction key?
Yes.
Okay, because I've had years where kids tell me no, and I'm like, I don't know how you made it. And it's not their fault; it's their teachers, whoever they
I
had
literally
before.
learned like halfway through last year.
I was like freshman year.
No one
What do we end up with here? 40. Let's see,
6.
46 out of 100.
60
I got 60 out of
Yeah.
Oh, I think
Okay,
I got
yeah,
3 out
60,
of 5.
which is 60 out of 100. That's just reduced.
Nice.
Yeah, 6/10, 3 out of 5. All right. Any questions from you? Yep, go ahead, Ava.
But if I write the symbol upside down, is it wrong on the test? But even if I do it right,
If
I probably won't notice it. I'm going to be looking for the 8 out of 100. Okay.
I feel like I'm gonna mess that up.
All right, here you go. Number 3. Okay, you're going to flip a coin and a spinner with those letters on it. What's the probability you get an H? Now, I can admit to my faults and embarrassments too. At first, I was like, why are we even bother doing this problem? You can't get an H because it's A through F. That's 0 possibility. And then I figured out H stood for heads. Yes. Yeah. So good one, Mr. Carlino. Yeah. Common sense out the window, right? What's the probability you get heads or a vowel? That's fine. Somebody asked it. Don't be. Somebody asked it first period too, what a vowel was. A-E-I-O-U. And if you're the kid who, well, sometimes why, get out of here. All right.
No, that's not what I was saying. I wasn't sure.
It's ready? Probability of a head or vowel. I'll just do a V-O-W here. Ready? So I'm going to do probability. It lands on heads. Plus or times? Plus the probability I spin a vowel minus probability of what? H and a vowel. Yep, and we know how to find that. All right, you ready to roll? Flipping ahead. I know we already went over it, but 12 flipping ahead, what's your probability? No 12 today?
Oh.
Hi.
Probability of getting a vowel. Wait.
Listen to the words that are coming out of my mouth. Probability of getting a head.
Oh, 1 over 2.
Okay, thank you. Now redeem yourself. What's the probability I get a vowel up here?
2 over 6.
Plus 2 out of, you guys want to reduce that? Go ahead. I'll leave it 2 out of 6. Minus, now here's where the first formula comes into play, right? Because I can't tell just from what they gave me. I'm not going to write it out. So how am I going to find the probability of a head and a vowel? Multiply heads and a vowel, just like we did in formula number 1. There we go. And then it's all calculator work.
Oh, for some reason I thought I was like, when I said vowel, I was like, all the vowels are on the spinner. Certain ones.
And we end up with, we got a fraction, 2/3. Yep. Now I just want a quick comment. This could also be a problem where you list out everything. HA, HB, HC, HD, HE, but I don't know. To me, it gets to a point where it gets a little ridiculous, listing out all these possibilities when I could just use a formula. All right, so we did and, we did or. We got to finish up on what was the other type of probability from yesterday? Given. Go back to your formulas. Yes. There's a formula to find the given probability. Here's your third and final one. Probability of A given symbol, vertical line given B. How am I going to find this? It's a fraction. On top, the numerator, goes the probability of A, symbol from today, and B. You guys know how to find that if it's not there for you, right? A times B. And on the bottom, you're always going to put the probability of whatever's been given. So for in this formula, I'm going to put a B, but every problem's not B though. Just realize in the denominator, you got to put the probability of whatever's been given. Okay? Two more, and then we're going to do a little practice right up to the bell. Whew. And there are the formulas again. Oh, there's my good old Boston and Knicks problem. So ready? What's the probability the Knicks win on Friday, given that it will rain in Boston on Friday? All right, so if I'm going to write this in my symbols I've been using all class, Knicks win on Friday, I represented that as W. Given, what do you want me to write? Vertical line. It rained in Boston on Friday for my R. Again, use whatever notation you've been using. Okay, if you rather have a K in there, a B, that's up to you.
Does it impact it? I feel like it does. Like if you use the order.
Darn right it does. Absolutely, it's going to matter. Because your denominator is going to be different. Ready? On top will be the probability of W and R. Okay, now this is where we got to be careful here and understand the formula completely. What's going to be on the bottom? The probability of whatever was given, which was rain, R. So that's going to go on the bottom. Guys, I get it. We already know the answer to the numerator because we did it in the first problem. We've been using that number over and over. But let's just say this is a fresh one. How do you find the probability of W and R from today? W times R, which would be 0.6 times 0.3. If we were doing this fresh. Over, what's the probability of rain? 0.6. So if we already knew it rained, what are the chances of the Knicks winning? 30%. Yep, Elliot, go ahead.
Why did you put 0.6 on the bottom instead of 0.3? Because what was given.
No. We were given that it rained, right? So that's got to go in your denominator according to the formula. Given that it rained in Boston. Okay? If I was given the Knicks won, yeah, then I put 0.3 at the bottom. Good question. Last one here together. Go back to my flipping a coin and my A, B, C, D, E. Looks like I left out F. What's the probability of getting a vowel given tails? getting a vowel given tails. So here we go, vowel given tails, however you want to write that. All right, go to your formula. What's got to go on top? Probability of
A
vowel and tail, which I don't have from a previous example, so we're going to have to calculate that. Over, be careful now, probability of what's given to us, what already happened? A tail. Yep. Oh, I love that we did not do this yet. How do I calculate the numerator? Okay, well, ready? One at a time. Val, what do you got for me? 2 out of? There's no F here this time.
2 out of 5.
2 out of 5.
Because
A
A
and-
are the only vowels.
A and E are vowels out of 5 letters.
A-E-I-O-U.
There's 5 letters here, not 6 anymore. A, B, C, D, E.
Yeah, but these
Vowel. Times tail.
1/2.
1/2 over probability of tails. 1/2. Now, again, serious talk here. Are you comfortable putting that in your calculator using your fraction keys?
Yes.
Okay, I'm just making sure because it's possible. That's what's great about the calculators. It's possible to have a fraction and then 2 fractions on top and 1 on the bottom.
Yeah, I still like the draw.
What do you end up with? 2/5.
Thank you, you're good.
Yeah, Ryan.
Have you just crossed out the 1/2?
You could. Yep, you could. Same thing up here. I could cross out the 0.6s. Yep, because we're multiplying. We are working right to the bell. Chromebooks out. Let's go. Let's go. Let's go. Next pages. Get your Chromebooks out. Look at the answer key. Next pages. Let's go. Let's go. I want to work right up to the bell. Don't pack up early.
I got tricky and bowling.
Example.